All right, let's go ahead and get started. This is Module F, Lesson 2. It's all about amplitude and period. And so last time we talked about how we have our sine and cosine graph. We graphed those. Today we're just going to add a little bit more onto that, and each day we're going to kind of keep modifying it a little bit. So last time we graphed the sine graph. Now this is what your graph should look like. We started at 0, 0, then the sine of pi halves is 1, sine of pi is 0, sine of 3 pi halves is -1, and then sine of 2 pi is back again at 0. Now the whole idea of amplitude, okay, if we look at this equation here, y equals a sine of k theta, the a in that equation is the amplitude, which just means the distance from basically the x-axis to the maximum point of our graph, or that crest of the wave. It's formally defined as half the distance from the top of our graph, the crest, the maximum point, to the minimum point. That definition is just because sometimes we do have a vertical shift, just like we saw in Module B, where we could shift the graph up or down a number of units, and then that would change how the distance from the origin. It wouldn't be symmetrical around the origin anymore. But that's something we can look at later when we start to do some vertical shifts, or when we translate it a little bit more. But for the most part, the amplitude we're just going to be able to measure from the x-axis to wherever it goes on the y-axis. So our maximum here on our normal y equals sine of theta is 1, and so the amplitude of our normal sine graph is just 1. Okay, so we'll work through some of these problems today. We are going to be learning amplitude, and luckily amplitude is very, very simple to actually find. The other thing we're going to do today, which is a little bit more work, it's maybe a couple steps instead of just looking at it, is the period of sine and cosine. We can actually modify the period, and that's what this k value does. It's just a multiplier. It's just some multiple of some number that you're multiplying that theta variable by. And what that actually does is modify the period of our function. So the formal definition of the period is, with that k value, is the period of a sine or cosine function is 2 pi divided by k. So 2 pi over k. So that k value, we'll take 2 pi, which is our normal period, and we'll just divide it by that k value. So we can look at, we'll look at those on the next couple problems, but let's start with amplitude. So for number 5, it says, which I know it starts at number 5, which is weird, but whatever. It's just how the numbering worked. Find the amplitude for the following instruction functions: y equals 2 sine of theta. Okay, so we're going to find, right, our a value. So y equals a sine k theta. The a is our amplitude. So our amplitude for number 5 is simply 2. Okay, so notice the 2 is highlighted, the a matches that. So our a is 2. Very, very, very simple. Now if I look at number 6, we have y equals -3 sine theta. So what is our a value there? Now you might be thinking, well, it's -3, right? Because that's what the a represents there. Now technically, yeah, I mean, basically, yeah, -3 is that, but specifically amplitude is a measure of distance. Now when we're talking about measure of distance, we want to make sure that we are remembering that distance is always a positive value. So distance are always positive, therefore our amplitude is going to equal 3. So whether it's y equals -3 sine theta or y equals 3 sine theta, the amplitude or the distance between the x-axis and the crest of our graph is going to be the same, right? It's still 3 whether it's +3 or -3. Okay, so let's talk a little bit about period. So to find the period of functions, we are going to remember that the period equals 2 pi over k. So for this one, number 7, y equals cosine of theta over 4. Right, we can rewrite that as y equals the cosine of 1/4 times theta, where k then would equal 1/4. Remember, it's y equals a cosine k theta. So k is that 1/4 value. All we have to do is plug it into our 2 pi over k. So we get the period equals 2 pi over 1/4. And that is 2 pi times 4 over 1, right? Because we keep the top one, change it from a division to a multiply, and then flip the bottom one to get a period of 8 pi. So that period, when we're dividing that angle of whatever we're plugging in the angle by 1/4, what we're doing is actually making the period 4 times longer. It takes 4 times as long for that function to make a complete cycle, to go one complete period. So from 2 pi all the way to 8 pi. Let's look at number 8. So y equals sine pi theta over 2. So that would make our k pi over 2. Okay, because our theta is there. Our k value is just all the stuff that's not theta, right? So we have pi over 2. So pi over 2 is our k. So we plug that in. We plug our k in. So we get 2 pi divided by pi over 2. We do the whole keep change flip. So we get period equals 2 pi times 2 over pi. The pi's will cancel out. And so we're just left with 4. So pi's cancel out. 2 times 2 is 4. So the period is 4 radians. Now that's not 4 pi radians, that's 4 radians. That's not even one time around the circle. That's almost 2/3 around the circle. So don't get that confused with 4 pi radians. Find the amplitude and period in radians for the following functions. This is number 9, y equals 10 cosine 7. Not sure what that is. That should be a theta. Something weird happened there. That is a theta, just go with it. So y equals 10 cosine 7 theta. And let's go ahead and look at the amplitude. Amplitude, remember, is just that first number out in front, so that's just 10. The period is 2 pi over k. Our k value is 7. And, sorry, little kids running in the room. All right, so 7, we put that with the k. And so our period is 2 pi over 7. That doesn't reduce, so that's it. We've got our amplitude and we've got our period. Number 10, we've got y equals -1/2 sine of, again, theta over 3. That's supposed to be a theta. It's not. So A, our amplitude is, let's see, we have a -1/2. Remember, amplitudes are always positive, so we just get a 1/2. Our k value, we're dividing by 3, so that's the same as a k of 1/3. The period is, again, 2 pi over k. And so we so we have our period is 2 pi times 3. All right, sorry. So we get 2 pi over, or times 3 over 1, which we get a total of 6 pi as our period. So 3 times as much as a normal one if we're dividing it by 3. All right. Let's keep going. So looking at the next ones, we have, this time we're writing an equation, so we're going the other direction. We're looking for a sine function with an amplitude of 2 and a period of pi halves. So amplitude, again, super easy. We have this base y equals a sine k theta. That's kind of the format that we're going to write it in. Our a and our k we need to figure out. So a, right away, we know the amplitude is 2. So that one's pretty simple. K though, last time we were given K and we needed to find the period. This time we're given the period, right? So that's this part of our equation, and we need to find K. So that means we're going to plug in our period of pi halves, and that's going to equal 2 pi over K. We can just do a simple cross multiplication here. So pi times K equals 2 times 2 pi or just 4 pi, and then solve for our K value by dividing pi on both sides. So I'll do that. Divide pi on both sides, and we're just left with K equals 4. So there's our K value. We know our A value is 2, the K value is 4, and so we can fill in those blanks. Y equals 2 sine of 4 theta. Alright, number 12 asks for a sine function with an amplitude of 6.7 and a period of 3 pi. So y equals sine theta, right? But we have our a and our k in there. Y equals a sine of k theta. So we need our a and our k, our amplitude, and this multiplier here. We know the amplitude is 6.7. It tells us that. Okay, amplitude of 6.7, and then our K value. Remember, we need to find our K value. We're given the period of 3 pi. So again, I plug it into that same period equals 2 pi over K. Okay, I'm trying to find the K. I'm solving for K. So I get 3 pi equals 2 pi over K. That then is the same as K equals 2 pi divided by 3 pi. Right, we can multiply K on both sides and then divide by 3 pi. To give us a total of the pi's cancel, and it's just K equals 2/3. So y equals, we plug in the amplitude, 6.7 sine 2 over 3 theta. Now you could write 2 theta divided by 3 or 2/3 theta. Either way, doesn't matter. Then we go to number 13. These ones are cosine, the same idea, just cosine instead of sine. So we're going to write an equation for a cosine function with an amplitude of 0.5 and a period of 0.2 pi. So I'm going to say y equals a cosine k theta. Same thing as the sine. Hi. Okay. Go back. Go back that way. All right. Once again, apologies. So we have our a cosine k theta. We know our amplitude A is 0.5. Okay. And then we know the period is 0.2 pi. So 0.2 pi equals 2 pi over k. We're looking for our k value. And again, I can solve it by saying k equals 2 pi over 0.2 pi. Now, pi divided by pi, that cancels out. 2 divided by 0.2 is the same as 1 divided by 0.1, or 1 divided by 1/10. So 1 times 10 over 1 is 10. So our k value is 10. Our a is 0.5. We get y equals 0.5 cosine 10 theta. Now on this next one, we get cosine function with an amplitude of 1/2. So I know right away my amplitude is 1/2. And a period of, again, that's supposed to be 2 pi over 5, not p. I'm not sure what happened here on my end, but 2 pi over 5, so 2 pi fifths. And so there we go. 2 pi fifths equals 2 pi over k. This one is pretty straightforward, right? 2 pi, 5. So k has to be 5 as well. So k is 5, which makes our equation, you can't see it there, but 1/2, right? 1/2 cosine 5 theta. And that's it. That is all. That's all that we've got to do. So go ahead and work on your homework assignment, and we'll check back when I get back on Thursday. I'll see you tomorrow.